Cool. So in the previous video, I went ahead and talked about graphing a quadratic equation. Feel free to reference that. In this video, I'm going to just do a quick little summary about the vertex and what we call an axis of symmetry. From the last video, I talked about it already, but your center of your table of values here, or if you were to see one on a given setup or scenario for a problem, for a quadratic relationship where you have a x squared term and it's a polynomial of degree 2, you'll see that your table or your graph is going to be centered about a given point. And I say centered here because you may notice there's a certain symmetry going on this graph where it's increasing up to here, then it's decreasing down over on the right-hand side, and it's doing so at the exact same rate. You notice these points are kind of one apart from the vertex in terms of your x location. Same thing with these 2 points. They're now 2 values away on either side. It's growing, or rather shrinking, or changing at the same rate in the same direction. So that central point we call the vertex. And here, of course, it's at a value of 1, 2, 3, 1, 2, 3, 4, or in coordinate planes or coordinate geometry, we can list that as 3, 4. Now, a word associated with vertex is that it's going to be, for a quadratic equation, either a maximum point or a minimum point. Now, the location of the vertex is the x coordinate of that. Like if I were to say, like, where's the vertex? You could list out the full point, but oftentimes it's going to be at an x value of 3, usually the x value. So if I were to write this like location of something, is often referring to the x value. You know, at what input do we have the maximum of the vertex? Well, at an input of 3, we get a output of 4, that is the vertex. And then oftentimes the value, that's going to be your y value. So value, output, or something like a maximum or minimum, that's referring to the actual value of a given graph. And you may notice the interesting change here is not that you're plotting the x coordinates, but rather the y coordinates, the height of your graph, if you think about it in those terms, changes at different rates, as opposed to the x, which we just keep plotting as we do normally. But the y value, the change in the y value is more interesting. Now here, when we say maximum and minimum, we're referring to other points on this curve. We don't care about the actual value of this, like if it's a positive number or a negative number or a decimal or whatever have you. We just care about relative to the other points that you plot, or the other points that are kind of subtly plotted here on the line, on this curve, on this parabola, quadratic equation. This point, compared to the rest, is higher. It's at what we call a relative maximum, or here in this case, it would be like an absolute maximum, because on the other side, it just keeps going down from there. This is the absolute highest point in the graph. So here, this will be a maximum for this graph. Now, lastly, as I mentioned, the vertex is kind of at that point for this graph where there's a big symmetry going on. So on either side of the vertex, the same rate of change is happening. It's going in the same direction. It's essentially a mirror image. The right-hand side and the left-hand side are mirror images of one another. In this way, we call this vertical line that goes through the vertex the axis of symmetry. So I'm going to abbreviate that as AOS, and that's down here, axis of symmetry. Now, vertical lines, you may note, have one interesting feature in that every single point on that line have an x coordinate of 3. And for that reason, the way we differentiate between vertical lines is just listing where it occurs. What is that common x value? In this case, it's going to be x equals 3. Now, we use the fancy word axis here because it's a special line in the context of this parabola. Other axes you might see, the word axis appears as like the y-axis, because that's for a coordinate plane, that's like always a central, important, useful, meaningful what could you say there? Object, perhaps? And same with the x-axis. So these lines, there's a bunch of other grid lines as well, but in the context of this problem, or just generally speaking, they're less meaningful. However, axis of symmetry in this case, we give it that special name because it actually is useful. It has that extra meaning of being that area, that location of the symmetry, where you can kind of imagine you fold one side of the parabola onto the other. And so here, the location is x equals 3. And that is axis of symmetry.